NASA researchers have found a glitch in the James Webb Space Telescope's mid-infrared instrument. The Webb telescope has provided scientists with stunning new insights into the cosmos beyond Earth ever since it was launched, most recently with the telescope's first photographs and spectra of Mars. An anomaly review board has been assembled by the space agency to look into the matter. NASA's JWST made what discoveries? Is there damage to the James Webb Space Telescope? We promise to address all of your concerns in this video, so please stay tuned and subscribe to the Future Space. The JWST's ultracold camera experienced a malfunction. One of JWST's most important instruments, the mid-infrared detection instrument, has been affected. Where do we go from here? Emergency! Houston, we have a problem. This well-known expression has been used countless times to convey the message that the situation is hopeless. It could just as easily be used for the JWST, which is experiencing a major problem around 1 million miles from Earth. The NASA JWST, which has spent the past 3 months stunning the globe with stunning, never-before-seen photos, has run into an unanticipated issue. There seems to be a problem with the space telescope. This problem affects the telescope's ultra-cold camera, which is connected to its mid-infrared instrument. MIRI is a crucial part of the telescope and its ability to gather high-quality photos. Because of this unexpected difficulty, scientists had to delay some observations that were supposed to take place this week. What will become of the JWST, though, casts a darker shadow. If the problem can't be fixed, would scientists be forced to do without a crucial feature? Well, let's check that out and see. Unexpected technological hurdles threaten NASA's James Webb Space Telescope. In particular, this problem has been affecting MIRI's grating wheel. Scientists rely on this wheel to change the wavelength of the light they're using to get a clear image of an object. Although the instrument is now somewhat worthless due to the wheel, it is not completely useless. In MIRI's medium-resolution spectroscopy mode, it is employed as one of the instrument's 4 observation modes. Spectrums of light can be recorded by the device in this mode. An official NASA announcement reveals that this issue was discovered by researchers in late August. The examination led to the decision to temporarily disable the feature so it can be studied. NASA officials stated in a statement that the Webb team has temporarily halted scheduling observations using this observing mode as they continue to investigate its behavior and create strategies to resume MRS observations as soon as possible. NASA seems determined to find a solution to the problem so that the project can go, so there's still hope. The observatory is healthy, and all 3 of MIRI's observing modes, imaging, low-resolution spectroscopy, and coronography, are functioning regularly and are still available for science observations, according to the statement. The JWST has run into unforeseen difficulties before. A meteoroid severely damaged its mirror in its early days of operation. In retrospect, NASA acknowledged that the force of the impact was larger than anticipated, but such impacts are not unprecedented for a space telescope. Let's see the importance of NASA's James Webb Space Telescope. In order to see the birth of the universe and the first stars come on, you need to grind a mirror the size of a house. The surface must be perfectly flat, with no bumps higher than an ankle's height, even if the mirror were the size of a continent. Light from the most distant galaxies in the sky has traveled a great distance from their point of origin. Only a mirror of this size and smoothness could capture and focus this light, revealing the galaxies as they were when the universe was young. When unknown forces converged in the shadows and the first crops of stars began to light, the faintest, most distant galaxies we would ever see were still in the process of being born. An exceptional mirror is not nearly enough to read that early chapter in the history of the universe, to learn about the nature of those first, probably gargantuan stars, to learn about the invisible matter whose gravity coaxed them into being, and to learn about the roles of magnetism and turbulence, and how enormous black holes grew and worked their way into the centers of galaxies. The ancient starlight that has traveled to us through the growing fabric of space for so many billions of years has become stretched, which is why no one has witnessed the epoch of galaxy creation. Light from the furthest stars in the sky has traveled at such a high speed that its ultraviolet and visible components have expanded to infrared over the course of its voyage. The enormous, flawless mirror within the telescope needs to be extremely cold so that we can see those distant stars. It's imperative that it be sent into orbit. The hitch, though, is that a mirror the size of a home is too big to fit in any rocket fairing. Therefore, it is necessary for the mirror to be collapsible. Only if the mirror is segmented, like a honeycomb, can it be folded? This is because a mirror with a continuous surface cannot be folded. However, for the mirror segments to be in a virtually perfect alignment after unfolding autonomously in space, they can collectively form clear images, which is essential. To get the focus right, you need motors so accurate that they can adjust each mirror segment by the width of a virus, half a segment at a time. The ability to observe faint infrared sources would not only provide a window into the universe's early history, roughly the first half a billion years after the Big Bang, but it would also shed light on other, arguably equally important aspects of the cosmos, such as the properties of Earth-sized planets orbiting other stars and the hotly debated rate at which space is expanding. But there's something else needed for the telescope to function besides a perfect mirror that automatically unfolds and focuses after being fired into the sky. The telescope still gets too hot from the Earth, Moon, and Sun, even in space, to pick up the faint glimmer of the farthest structures in the cosmos. That is, unless the telescope is pointed towards Lagrange Point 2, which is 4 times further from the Earth than the Moon. When the telescope is positioned there, a sun shield the size of a tennis court may be erected to shield it from the Sun, the Moon, and the Earth all at once. In this way, the telescope is shielded from the Sun and can enter a deep cold, allowing it to pick up the faint heat of the cosmic dawn for the first time. Sun shields are the infrared telescope's savior and their downfall at the same time. The sun shield needs to be made of light cloth so that it may expand to a big size without adding too much weight to the rocket. A big ground-based telescope is typically much heavier than the entire observatory, which includes mirrors, cameras, and other instruments, as well as transmitters and power sources. The use of fabric in the construction of a massive yet lightweight infrared sensing spacecraft is inherently dangerous, but that's to be expected given the complexity of the task at hand. Engineers use the phrase non-deterministic to describe the nature of the fabric, which makes its movements difficult, if not impossible, to fully control or anticipate. The telescope as a whole will be rendered useless if the sun shield becomes stuck while being unfurled. The incredible telescope is now folded up and waited to be mounted on an Ariane 5 rocket. More than 30 years after the JWST was initially conceived of and sketched, the rocket is set to go off from Kourou, French Guiana, on December 22. The telescope's cost has increased by a factor of 20 from its original estimate, and it is 14 years behind schedule. John Mather, the astronomer who won the Nobel Prize and has been the principal scientist of the NASA-led project for 25 years, stated, "We've worked as hard as we could to catch all of our faults and test and rehearse. The time has come," he continued, "to place our zillion-dollar telescope on top of a heap of explosive stuff and leave the outcome to chance." Does NASA plan to give James Webb a new name? What do you think? Let us know in the section below, and that's all for now. And if you like what you see, subscribe to our channel so you never miss an amazing video.